Hi guys, you're back here with Feynman Education, and today we're going to go through the Pearson Edexcel International A level, so the IAL, for the May 2019 Maths P1 paper. You can use this as a mark scheme, or you can either, check all the necessary working out that you'd need to show to get all the marks, or as a guide on how to approach certain questions, because they tend to repeat a lot of similar questions with different numbers. So for the first question, it gives you an equation, y equals an eighth x cubed minus 24 over the root of x plus 1, find dy by dx. So I would start off by converting this and bringing all the powers of x to the top. And now it becomes much easier to differentiate because we can multiply the powers. So we get 3/8 x squared plus 12x to the power of minus 3 over 2. And you can leave your answer like that, or you can rewrite it as this. Either or. The point 4 minus 3 lies on this curve. Find the equation of the tangent. So remember, dy by dx gives us the gradient. So the gradient when x equals 4 would be, we just need to substitute 4 into this equation. And 4 to the power of 3 over 2 would be 8. And if we were to work that out, we would get 15 over 2. And now we can substitute in the y coordinates. We get y is equal to 15 over 2x plus c. So minus 3 is equal to 15 over 2 times 4. So minus 3 is equal to 30 plus c. And we get c is equal to minus 33. And if we rewrite that, we get y is equal to 15 over 2x minus 33. And that is the form that it wants it in. So be very careful to give it in the exact form that they have asked for. For the first part of question 2, this is asking you to rationalize the denominator. So remember, you need to show all your working out in order to get the marks. You can't just put it into your calculator. And to rationalize the denominator, we would times the top and the bottom by the same denominator, but change the sign. So if it's negative, we make it positive. If it's positive, we make it negative. And on the top, we're going to get 4 plus 2 root 2. And on the bottom, we're going to get 16 plus 8 root 2 minus 8 root 2 minus 8. And that would give us 4 plus 2 root 2 all over 8. And now it says a and b are rational numbers, and it wants it in this form here. So we can split it as 4 over 8 plus 2 over 8 root 2, which would give us a half plus a quarter root 2. Now it says, hence or otherwise solve this equation. So what we know from this equation is we have 4x equals 2 root 2x plus 20 root 2. And over here, we want to get something quite similar. So we can have 4x minus 2 root 2x is equal to 20 root 2. And we can separate this as x. 4 minus 2 root 2 is equal to 20 root 2. And here we get x. If I divide it, that's the same as me multiplying by 1 over 4 minus 2 root 2. And we have already worked out that this is equal to this. So that would be the same as 20 root 2 times a half plus a quarter root 2. So this would give us 10 root 2. And if we were to work this out, we get 20 root 2 times a quarter root 2. And that would be the same as plus 10. So here it says we're given certain sides, and it says that given that the perimeter of the garden is greater than 29, so we just need to add up all the sides. So remember, this side here is going to be 6x minus 2 minus 2x plus 1, because the minus would change the sign of that, which would give us 4x minus 1. And this length here would be 3x. So if we were to work out the perimeter, we just need to add all the sides. 2x minus 1 plus 2x plus 4x minus 1 plus 3x plus 6x minus 2 plus 5x has to be greater than 29. And if we collect all of our x's, we get 2x, 4x, 8x, 11x, 17x, 22x. And here we get minus 1, minus 2, minus 4. And we get 22x is greater than 33. X must be greater than 1.5. Which is what it wants us to show. So it says, given that the area is less than 72, form and solve a quadratic inequality in X. So with this, we can separate this shape into two shapes, really. So we can separate it here. We have the top part and the bottom rectangle as well. So if we were to work out the area of the top part, it would be 2x minus 1 times 2x plus the area of the bottom rectangle would be 6x minus 2 times 3x. And it says that the area is less than 72 meters. This would give us 4x squared minus 2x plus 18x squared minus 6x is less than 72. If we were to add these together, we get 22x squared minus 8x. Bring the 72 across. Minus 72 is less than 0. We can divide everything by 2. So you get 11x squared minus 4x minus 36 is less than 0. Now that looks pretty difficult to factorize easily, so you can use the quadratic formula. And your answers, remember, if we were to write it out, would be 4 plus or minus square root of 16 minus 4 times 11 times minus 36. So plus 1584 all over 22. So x would either equal plus root 16 plus 1584 over 22, would either equal 2 or x would equal minus 18 over 11. Now, if we were very quickly to draw a quadratic graph, it would look like this. And it's strictly less than. So in that case, we'd have to be between these 2 points. But what you need to remember is that x is a length, and this length can never equal 0. So in that case, x has to be bigger than a half, but less than 2. So less than 2. And that would be our inequality. And hence find the possible range. Well, including the first range, it said it had to be bigger than 1.5. So it'd be between 1.5 and 2. Now it wants us to integrate this. So when we integrate this, what I would suggest doing is again separating it. So you get 4x squared over 2 root x plus 1 over 2 root x dx. And if we were then to simplify these, we would get 2x to the power of 1.5 plus a half x to the power of minus a half. So remember, when we integrate, we raise the power by 1 and divide by the new power, which would give us 4 over 5 x to the power of 2.5. Raise the power by 1, that becomes a half, so plus x to the half, and don't forget your plus c. Plus c is very, very, very important, and you will always need that plus c. Now it wants us to find all real solutions of this. So if we have 2x cubed plus 3x squared minus 35x equals 0, we can immediately pull out an x from each term, and then we have a quadratic, which the quadratic we can factorize. And if we have 7 and 5, we can have plus 5 minus 7. So we know that either x equals 0 or 2x minus 7 equals 0, which means x equals 7 over 2, or x plus 5 equals 0, which means x equals minus 5. Those would be all the solutions. And what we've done with the next one is we've just replaced x with y minus 5 squared. And we have the same exact equation. So we can say if x is equal to y minus 5 squared, we can think about all the other solutions. So we can say y minus 5 squared is equal to 0, which means y minus 5 is equal to 0, so y is equal to 5. Or we can say y minus 5 squared is equal to 7 over 2, so y minus 5 is equal to plus or minus root 7 over 2, y is equal to 5 plus or minus root 7 over 2. And lastly, y minus 5 squared is equal to minus 5. But we cannot square root a negative number, so that gives us no solutions. The line with the equation y equals 4x plus c, where c is a constant, meets the equation at this point. So if it meets it at one point, we're going to make them equal. And what we're going to do is multiply out the bracket. So you get x squared minus 3x, and collect all the terms. So I'm going to get x squared minus 7x minus c is equal to 0. And if it only meets at one point, that means b squared minus 4ac equals 0. So I'm going to get 7 squared minus 4 times 1 times minus c is equal to 0. So 49 plus 4c is equal to 0. Or again, it could be plus c. And here we've got 4x plus c equals x squared minus 3x. We've collected all the like terms. And if it meets at only one point, we're going to have minus 7 squared, which is 49, minus 4 times 1 times c, which would be times minus c, because that would be a minus c if we've taken it to the other side. And that means 4c is equal to minus 49. So c is equal to minus 49 over 4. And hence find the coordinates of the points of intersection. So now we can just simply put that in. So if we have x squared minus 7x plus 49 over 4 equals 0, we can use our quadratic formula. So x would equal 7 plus or minus, well, we know this is going to be 0, all over 2, which would just be 7 over 2. And by doing that, we can substitute that value into either y equation. I would suggest doing the one that they have given you the full equation for. And this would give us an answer of, which would be 7 over 4. So the coordinates would be 7 over 2 and 7 over 4. With the Radians questions, it says, find the area of the sector ABCOA. So remember, this angle here is going to be 2 pi minus 0.7. So for the area of that sector, it's a half r squared theta, which would be a half times 6 squared times 2 pi minus 0.7, and it wants it to one decimal place. And that would give us 100.5. And given the angle ADO is obtuse, find the size of the angle. Well, what we know is we have a triangle that looks something like this, where this is 0.7, this is 6, this is 5, and we want to find this angle here. So we can use the sine rule, and we can say sine theta over 6 is equal to sine 0.7 over 5. Sine theta, where this is theta, would equal 6 sine 0.7 over 5. So theta would equal sine minus 1. 6 sine 0.7 over 5, and it wants it to one decimal place. Over 5. Make sure your calculator is in radians. And that would give us 0.883. But it says that it is obtuse. So remember, for sine, we'd have to do pi minus that. And the answer would be 2.258. And it says, hence find the perimeter. Well, now that we know that angle, what we want to work out is the length of DO. So we know this is 0.7. This is 2.258. So this angle is pi minus 0.7 minus 2.258. This is 6 and this is 5. So we can do pi minus 2.258 minus 0.7, which gives us 0.184. And we can use the cosine rule to find out this length. So we know x squared is equal to 6 squared plus 5 squared minus 2 times 6 times 5 cos 0.184. And then if we square root all of that, we would get 6 squared plus 5 squared minus 2 times 6 times 5 cos 0.184, which leaves us with x equaling 1.4187 ... which would be the length DO. Now we know that CD would equal 6 minus x, which would give us 4.58 to 3 significant figures. And if we want to find out the area of A to C going round the circle, remember that's just r theta, which should be 6 times 2 pi minus 0.7, which would be 33.499, and so on. Now we can simply add up all the values. So it'd be 33.499 plus CD, which we said was 4.58, plus 5. That would be the total perimeter, which would give us 43.1 to 1 decimal place. And this equation says that the curve with the equation y equals f of x passes through this point 41. Given that f of dash of x is this, find the equation of the normal to C at P. Okay, so we know that the gradient of the tangent at P would be 4 root 4 minus 2 minus 8 over 3 times 4 squared, which would be 8 minus 2 minus, that would give us 16 times 3, 8, minus 1 over 6. That would give us 35 over 6. So the gradient of the normal at P would be minus 6 over 35. And we can just do y equals minus 6 over 35x plus c and substitute in the values. 1 is equal to minus 6 over 35 x plus c. But rather than x, we're going to put in the value of 4. And we would get c is equal to 59 over 35. So we get y is equal to minus 6 over 35x plus 59 over 35. We can times everything by 35. So 35y equals minus 6x plus 59. And take everything to one side. So we're going to get 6x plus 35y minus 59 equals 0, which is what they wanted. Now to find f of x, we'd have to integrate that. So for the second part, if I am going to integrate 4x to the power of a half minus 2 minus 8 over 3x to the power of minus 2 dx, well, remember we are going to raise the power by 1 and divide by the new power. So I'm going to get 8 over 3x to the power of 1.5 minus 2x plus 8 over 3x to the power of minus 1 plus c. And now we know that they must be equal when at that point p, so 4, 1. So I'm going to say 1 is equal to 8 over 3, 4 to the power of 1.5, minus 2 times 4, plus 8 over 3 times 4 plus c. And here I'm going to get 64 over 3 minus 8 plus 2 over 3 plus c is equal to 1. And this will give me 1 is equal to 14 plus c. So c is equal to minus 13, which means y is equal to 8 over 3x to the power of 1.5 minus 2x plus 8 over 3x minus 13. And that is very important that you rewrite it including the plus c that you have found. And here it shows what y equals sine theta. State the coordinates of the minimum point. So the minimum point, we're not going to change the x coordinate. So it's going to be 270 degrees. And the y coordinate, 1 minus 1, will become minus 4. Because it only asks for the minimum point. And here it's asked you to draw 1 plus sine theta for the following. So 1 plus sine theta means that we have moved everything up by 1. So we'd have a point here, and each point on the graph has moved up by 1. So this is the 1 plus sine theta. And it wants you to also draw y equals tan theta. So remember with tan theta, we're going to start here. It's going to shoot up, go through that point, and go back again. Right? So the number of solutions that lie in this region. So remember, in a 360 degree region, we're going to have one solution and two solutions. So we can do 2160 divided by 360, which would be 6. So if we have two solutions, here we're going to have 12 solutions. And here we can do 1980 divided by 360, which means we're going to have 5.5. So we're going to have 5.5 times 2, which means we're going to have 11 solutions. The curve has the equation y equals f of x, where f of x equals that. The curve touches the x-axis at point P and crosses the x-axis at point Q. So if it only touches the x-axis at point P, that means that's what the repeated root is. So that'll be here. So we get -1/2 and 0. Find f dash of x. So here there are several ways in which you could do it. You could either use some of the differentiation rules, whether it be product or chain rule, or you could even multiply out the whole thing. So let's use the product rule. I'm going to say u is equal to x minus 4, which means u dash is equal to 1, and v is equal to 2x plus 1 to the power of 2. So v dash is going to be 2 times 2, 2x plus 1 to the power of 1, which is the same as 4 times 2x plus 1. And here we're going to do v u dash plus u v dash, which would give us v u dash, we're going to get 8x plus 4 times x plus 4, that's uv dash, sorry I've written it the wrong way around, plus 2x plus 1 squared. Now in its simplest form we can multiply all of this out. So we can get 8x squared plus 36x plus 16 plus 4x squared plus 4x plus 1. If we collect like terms, we get 12x squared plus 40x plus 17. Hence show that the equation of the tangent to the curve at the point where x equals can be, so the equation of the tangent to the curve where x equals that can be expressed in that form. Okay, so if we say the gradient when x equals 5/2, what we're going to do is substitute that in. So we're going to get 12 times 5/2 squared plus 40 times 5/2 plus 17. That's going to equal. So here we're going to have 12 times 5/2 squared plus 40 times 5/2 plus 17 is going to equal 192. Now when x equals 5/2, the y coordinate is going to equal 5/2 minus 4 times 5 plus 1 squared times, which would be minus 54. And what we're going to get here now is y is equal to m, our gradient, which is 192 x plus c. So minus 54 is equal to 192 times 5/2 plus c. Which is going to be minus 54 is equal to 480 plus c, I'm just going to check that we've done this absolutely correctly. So we've got uv dash. Oh no, we haven't. This is going to be a -4, which would change a lot of these, and possibly our answer completely, which would make it a lot more simple. But it's the same method really. It should have all cancelled out pretty nicely. So let's see what we get. And here we would get 8x squared minus 32, so minus 28x minus 16 plus 4x squared plus 4x plus 1, which gives us 12x squared minus 24x minus 15. So the gradient would then be 12 times 5 over 2 minus 24 times 5 over 2 minus 15. So our gradient would be 0, and when x equals that, and when x equals 5 over 2, y would equal, well, we can just put that into the same equation, which was minus 54. And now this changes everything. Because we had 0x, so minus 54 is equal to c. So that means y is equal to 0x minus 54, which means y is equal to minus 54. The curve of the equation where a is a constant passes through the origin. So if it passes through the origin, that means either point Q, which is 4, 0, passes through the origin. So that means a can equal 4, as we've moved it to the left by 4. Or a can also equal minus a half, as that means we'd have moved it to the right by a half, and that means point P would then go through the origin. And that is the final question. So, please like and follow our videos, or comment below if there was any question that you didn't understand that you wanted us to go through, or even if there were any other papers that you would like us to go through. We'd be more than happy to answer those questions. Don't forget to subscribe, and we'll be uploading a lot more content in the coming days. Thanks, guys.